this way. Then integrating this will give us axn plus 1 over n plus 1. And this formula is very, very important. Integration plus c, put it there. So if we have to integrate this, then it will be, we add 1 to this, we transfer that down and add it. So likewise, the one I was talking about, y equals to x, dy dx will definitely be 1. Then we cross multiply. So dy equals to dx. So if I integrate this, y, then this one will be x plus c. So that is how we are doing it. So here, that means if we integrate 1, we're going to have x. So this formula is very important in integration. So we're going to consider some examples so that we can apply this formula to integrate some questions. And by so doing, look at the question in example 1. If you have integral of x squared plus 3x plus 4 dx. The second one is 2 into x plus 3 over x cubed dx. If you are to integrate the first one, which is the a, then we have integral of x squared plus 3x plus 4 affected by x. Now, we have, if you are to integrate this, we have x squared plus 1 over 2 plus 1. That's this first one. Because it can go this way too. You can integrate x squared affected by dx plus another 3x affected by dx plus another 4x affected by dx. What I have done is to distribute the integral sign to the respective terms. This. We can do that in integration. Integral of this, integral of this, integral of this. Then when you integrate this one becomes x squared plus 1, 2 plus 1, plus this one becomes 3x, 1 plus 1, 1 plus 1, plus this one, this 4 has x raised to power 0, but because of the fact that the power of this does not favor the appearance of that is why it is not appearing here. So definitely you have this. So you are saying 4x0 plus 1, 0 plus 1. And plus c. Why do we need to add plus c at the end? Is because we are dealing with indefinite integral. If you are dealing with indefinite integral, we add plus c. Take note of that. And what do we mean by indefinite integral? That's the integral that does not have the range of values. Does not have the upper limit and lower limits. So you add plus c. So here we have x cubed over 3 plus 3x squared over 2 plus 4x over 1 plus c. So at the end we're going to have x cubed over 3 plus 3 over 2x squared plus 4x plus c. So this is the answer for the first case. Now in the second case, you have integral of 2 into x plus 3 over x cubed dx. If you are to integrate this, let's expand this. We have 2x plus 6 over x cubed. Then dx. So I can write this one as 2x over x cubed plus 6 over x cubed dx. Still the same. Then this 1x can cancel 1x, so you have x squared. So automatically you have 2 into x squared plus 6 over x cubed dx. So this one can be written as integral of 2x raised to the power minus 2 plus 6x raised to the power minus 3 dx. Then now let's integrate this. So everything is affected by this. So I can integrate this as 2x squared and 2x raised to the power minus 2 dx plus integral of 6x raised to the power minus 3 dx. So here I will have, if I integrate this, I will have 2x minus 2 plus 1 minus 2 plus 1 plus 6x minus 3 plus 1 minus 3 plus 1 plus c. So this one will give me 2x minus 1 minus 1 plus this one will give me 6x minus 2 plus c. And this one will now give me minus 2. This one comes down, x minus this minus 6 over 2x squared, then plus c. So these two can cancel these 3. So we have minus 2 over x minus 3x squared plus c. And this is the figure of the second situation. So that's the B part. This is answer to the B part. Now let's talk about integration by substitution. Integration by substitution, a typical example, let's consider integral of x plus 1 all cubed dx. We have integral of x plus 1 raised to the power cube dx. This is a typical example of integration by substitution. So if you have to solve any question that has to do with integration by substitution of this nature, that's when you have x plus, your function x plus 1 is having more than one coefficient, more than one raised to power, more than one power, because the power here is 3. So automatically you cannot integrate this directly, rather than resulting into integration by substitution. And if you are to integrate this by substitution, the first thing you do is assume that let u be what you have in the bracket as x plus 1. Then your integral becomes u raised to power 3 dx. So what you do here is you differentiate this with respect to x. So du dx will definitely give us, if you differentiate x, you have 1. If you differentiate this 0, that's a constant. So automatically you can cross multiply this. So then du becomes dx. So you can't integrate u with respect to x. You can only integrate u with respect to u, or you integrate x with respect to x. So here your dx is equal to du, so I can replace my dx with du. So then I'll have integral of u cubed du. Then I can now integrate this. If I integrate this, it will be 3 plus 1, 3 plus 1. So that will be u raised to power 4 over 4. And what is my u? My u here is x plus 1 over 4 raised to power 4 plus c. So this is the answer. And this is what is known as integration by substitution. Because subsequently, when we talk about in the definite integral situation, we will need this concept. That is why we have to treat this before definite integral. Now we have solved questions dealing with indefinite integral. Now it's the time for definite integral. So example 1, find the value of this. So here, this is a typical example of definite integral. Why? Because it has an upper limit and a lower limit. So in this situation, we have definite, we are talking about definite integral. Talking about definite integral. So in this situation, we're going to have integral of 1 minus 2 into 2t minus 3t minus 2 dt. Now in this situation now, that means we have to integrate this. We have to integrate it, that will be 3t squared over 2 minus 2t over 1. Then we have the upper limit and the lower limit, 1 minus 2. So the next thing we have to do now is we substitute anywhere we see our t, we replace it with this and subtract it from when we replace it with this. So what am I saying? That means the first case you have this, so you have 3 into t here, t squared, that will now be 1 squared over 2 minus 2 into 1 over 1. That's the first case. You put in a bracket and subtract it from when you replace it with this. And that will be 3 into minus 2 squared over 2 minus 2 into minus 2 over 1. So here, this one becomes 1 square, 1 times 3, 3 over 2 minus 2 over 1. Have this one in bracket, minus, this one will be minus 2 squared, that's 4. 4 times 3, 12. That's 12 over 2. Minus 2 times minus 2 plus 4. Plus 4 over 1. So automatically this one will give us, can look for the LCM of these two. 3 minus 4. Minus 4. Then minus 2 here 1, 2 here 6. 6 plus this, that's 10. 10. And this one will give us minus half minus 10. That will be minus 10 and a half. That's the answer. So that is how to resolve question that has to do with definite integral. The two limits that are given. You substitute the first one, you calculate what you have minus the second one, and you arrive at that. And that's a typical example of concept of definite integral. Then example 2, we have to solve this. It's another case. We have integral of 1, 0 into x squared minus 3 dx. So we integrate this. So if you have to integrate this, we have to integrate x squared minus 3 dx, which is equal to